surprising what kind of energy it is. Do you know, Brian? Pardon?
What was that?
What kind of energy would it be in the boiling step? When it went from being very hot water, the molecules moving faster, to boiling. It's a little surprising.
Some kind of chemical energy.
It isn't, because there's no bonds being formed or broken when water is boiled. It's the H2O is the same in the water as it is in the air once it's
Well, the
water vapor.
So then is it like
It's a little
electrical?
surprising. What?
Is it electrical then? Or
It isn't. We had some
Well, the water
electrical
vapor-
in the
wouldn't the water-
coil. Pardon?
Wouldn't the water vapor be water molecules that are disconnected with each other?
They don't disconnect. They just move faster. So because the only thing is moving faster, which of these energies, Brian, do you think it would be? It's going to surprise you. But
Mechanical?
it is again. Isn't that
Mechanical.
odd? It doesn't sound like
I know, it doesn't sound
water is
mechanical.
mechanical, but because it's only motion
Like
involved, it is mechanical. So, very interesting. All right, so now we're poised to do a problem. All right, let's do, if you would, on your paper on that day somewhere, draw a car, toy car, 230 grams. Right away, when I see 230 grams, I switch it right away to kilograms. I don't even read the rest of the problem. So I move the decimal over 3, and I put 0.230 kilograms. So that's my method, so I don't forget. All right, so let's say that someone has pushed this car and given it kinetic energy, and we know the kinetic energy. It's 0.46 joules. And the question is, how fast is it moving when friction has done 0.30 joules of work? How fast is it moving when friction has done 0.30 joules of work? So once I push it and I've given it kinetic energy, the only force doing any work, remember, work requires a force. After I push it, I've stopped pushing it, and it's gliding along after my push. The only force that's doing any work at all from then on is friction. So you can answer this question with just knowing how much kinetic energy, we're going to take the amount of kinetic energy and find the velocity from that. So why am I using kinetic energy formula? Why am I using the kinetic energy formula to answer a question about friction? Because all friction is going to have to remove all of this kinetic energy. So I can use it to answer a question about friction. So it's one of those cases where we're going to use one form of energy transferring to another, and I'm going to use the formula from the one that doesn't normally apply to the other. So how much, if there was 0.46 work done by kinetic energy, let's say we're going to take out 30 of that due to friction. So we're going to take KE minus the work done of friction, work from friction, and I'm going to get 0.46 is what I started with. It says when friction is done 30 joules, so when I subtract, I'm going to get 0.16. That's the work that's remaining. And that's what I want to know about at that point. What is the velocity? How fast is a question about velocity? So I'm going to take this number and put it in here. So kinetic energy is going to be replaced with that amount of work that's left. Notice how I exchanged work and energy. I can do that. They're both in joules. So we know the mass. So tippy tap, 0.230. Remember the last step is a square root. All right. So take out your calculators, tip tap.
Tap A. Why is physics less confusing?
True.
Don't get that.
Yeah, I know. It's,
You have your calculator, Brian? Got an answer?
she's so busy. I don't want to
Alright.
Same. I don't.
Let's see.
Too much more life to do right now.
do it all. Why did I just do that?
Alex, would you share your answer when you got it?
Yes, I got at 0.21.
No, let's see what happened. Did you, what was your first
Subtracted it.
step? Did you take half of 0.230,
Yeah,
0.5, or 1
I
half?
got 1.1.
Alright, and
And I did point. I
then
subtracted that.
divided into
Divide.
this,
I divided it.
divided this by whatever that was,
Okay, so
and
do,
take the square root.
okay. Okay, oh never mind. I got 1.18.
Alright, I'll say 2 for sig fig's sake.
True.
Anyone confirm?
Okay.
Alright. Alright, notice then, are you trained now? The only energy in the beginning was kinetic, but friction robbed it. Robbed, the energy source was heat due to friction, robbed this kinetic energy of 30 joules, 0.30 joules. So we had to find out how much energy was remaining. So this was the amount of joules of energy that were remaining. At that point, it's all kinetic, there's nothing else. So I'm going to set that amount of work equal to the kinetic formula and solve for V. Does it make sense in your head why I could do all that? All right, so you're in training. That's problem number 1. You got it down? Can I erase it?
Sure.
I'll put the next one here just in case someone still needs it. So I'll write a little smaller. I wonder how many minutes we've gone. Let's start at part 2 because I'm not sure
Yeah.
I forgot.
I'm going for a little
I keep
too long now.
forgetting.